You know that teeth gritting moment, right? You're driving along, maybe lost in thought or listening to something, and then wham! Your car disappears into what feels like, I don't know, the Grand Canyon of potholes.
Ugh, yeah. It's a never-ending battle, these road
It
craters.
really is. But imagine if technology could actually smooth things out for us, maybe even proactively.
Well, it's not just a pipe dream anymore. What's really interesting, I think, is seeing how artificial intelligence is moving from, like, science fiction to becoming a very practical tool in tackling this incredibly persistent problem.
Exactly. And that's the rabbit hole we're diving into today. We're looking at how AI isn't just spotting these road hazards anymore.
But even trying to predict where they might pop up next.
Right. So we've gathered some really fascinating pieces to look at for this. There's a CBC News Alberta video showing what Edmonton is up to,
Sure.
and this really detailed research paper from the Philippines called iWay, an artificial intelligence of things pothole detection system with map visualization.
Sounds technical.
Yeah, it is. But then there's a KGW news clip out of Oregon City, some insightful YouTube videos explaining the core tech from places called Cotwell and Pyre Search.
Ah, the underlying stuff. Good.
Exactly. And even a report from BBC News about what Surrey is doing over in the UK.
Quite a global perspective then.
Hmm.
So our goal today basically is to really get under the hood, understand the different ways AI is being used to fight this pothole war.
Yeah, see what the tech looks like in action and, what the potential is for making road maintenance a whole lot smarter.
Okay, makes sense.
So let's start by thinking about how we've always dealt with this the old school way and how AI is, well, shaking things up.
Right, the traditional method.
We all know the drill.
Yeah,
You hit a pothole hard enough to rattle your fillings, maybe you call the city, maybe fill out some form online. It's all very much after the fact, isn't it?
precisely. Traditionally, it's relied heavily on people like you and me reporting issues or on manual inspections by road crews,
Mm.
which, as we'll see, has some pretty significant drawbacks. Well, that Edmonton video gives a good illustration. They mention how, in the past, city staff had to manually sift through calls and emails, trying to figure out if multiple people were complaining about the same spot.
Oh, wow. Like putting puzzle pieces together.
Exactly. And then someone had to physically look that up on a map, a very, very time-consuming way to piece things together.
Okay, and that Edmonton video, it talks about their new tool, right? An app called Repair.
Yeah, that's the one. It automates all of that. It instantly groups together reports from the same area and links them to map locations.
Ah, so it saves a huge amount of staff time then.
A massive amount.
Yeah.
It's like going from, slow detective work to having this clear, instant overview.
Right.
And if we zoom out a bit, that iWay paper, the one from the Philippines, it really emphasizes just how inefficient those traditional methods can be sometimes.
How so?
They describe the manual pothole detection process there as incredibly time-consuming, needing a lot of manpower and being really costly.
Like how costly?
Well, they actually give a figure, around PHP 4,000 per kilometer. That's their currency, just to inspect 250 kilometers of road. And it could take 2 to 3 months to do it.
2 to 3 months just to check 250 kilometers. Wow.
Yeah, it really highlights the significant technological gap.
Yep.
The difference technology can make in some regions. Imagine spending months just identifying the problem.
That really puts things into perspective. That's where the promise of AI starts to shine, isn't it?
Absolutely.
Okay, so let's dig into how AI is being used right now, starting with Edmonton and how they're using it for, like, prediction.
Yeah, what's particularly clever about Edmonton's approach, I think, is that they're not just fixing the potholes they know about.
Uh-huh.
They're trying to anticipate where new ones might form. Their repair app, like the CBC report explains, uses a massive amount of historical data.
How much data are we talking?
62 weeks worth of 311 pothole complaints. All that information is fed in to spot patterns and predict areas that might be more susceptible to pothole development down the line.
And the scale of the problem there is huge, right? The video mentioned, what was it, over 1.7 million potholes filled in the last 3 years.
Yeah, 1.7 million. It's an astronomical number, as the reporter put it.
Yeah.
And that huge number isn't just a statistic. It represents a massive data set.
Which is crucial for the AI, I guess,
Yeah.
to learn effectively.
Exactly. That volume of historical information is a key ingredient for successful machine learning, for making, accurate predictions.
So using all that past data to try and get ahead of future problems, that seems like a really smart way to use resources.
It absolutely is. This ability to predict allows the city to shift from just being reactive fixing them as they're reported,
Sort of chasing their tails.
to being proactive. They could potentially send maintenance crews to these at-risk areas before the potholes even become major headaches for drivers.
That sounds incredibly efficient. But the CBC report did make a key point, didn't it?
It did.
Even with this AI prediction, the city still relies on residents reporting potholes through their 311 system.
That's right. So it's a combination. Citizen input plus AI analysis. The AI is making really smart use of the information they receive, but that initial trigger often still comes from the public.
Okay, it's about making the most of the data they actually have access to.
Exactly. Now let's maybe switch gears a bit and look at a system designed for detecting potholes in real time. That Highway project in the Philippines.
Okay, this sounds really cutting edge. The paper calls it an AIoT prototype, artificial intelligence of things.
Yeah, AIoT. And it's specifically designed for spotting potholes in real time, tailored for the conditions found in the Philippines.
So what tech are they using?
Well, what's really fascinating here is how they're bringing together several advanced technologies. The paper details using sophisticated computer vision algorithms, basically teaching a computer to see potholes,
Right.
along with something called AI on edge technology.
AI on edge, what's that?
It means the AI processing happens right there on the device itself. In this case, exactly. And that's really beneficial because it allows for immediate detection without needing to send huge amounts of data to a remote server. It makes the system faster, more reliable, especially if internet connectivity is spotty.
Makes sense.
And they also incorporate real-time map visualization so they can instantly see where the detected potholes are located on a map.
And the results they got sound pretty impressive. The paper mentioned, what was it mean, average precision, MAP, of 91.8%?
Yeah, almost 92% MAP and a testing accuracy of nearly 83%.
Wow, and super fast, too, like 1.76 milliseconds inference time, using something called YOLO 5 meter.
That's it. Now, think of MAP as a really robust way to measure how accurately the AI is identifying and locating the potholes. Nearly 92% suggests very high precision.
Much better than just relying on someone spotting them visually, I bet.
Oh, significantly better. And that speed, that near real-time detection is key for a system like this.
Right, you need to know now. And the hardware wasn't anything too exotic either, was it? A Raspberry Pi 4?
Yeah, just a Raspberry Pi 4, that small, affordable computer, a GPS module for locations, and a camera. It's a pretty accessible technology, used in a really innovative way.
The paper also mentioned they followed a very structured process, CRISPM.
Right, CRISPM. It's a well-regarded framework for data projects like this. The paper explains how they went through the 6 stages.
Okay, walk me through it quickly.
Sure. First, business understanding, recognizing the high cost and inefficiency of those manual surveys in the Philippines we talked about.
Got it. The why.
Then, data understanding, analyzing the kinds of pothole images they had. Next, data preparation that involves resizing images, maybe tweaking colors, augmenting them to help the AI learn better.
Okay, prepping the ingredients.
Then modeling, actually building and training the AI model itself. After that, evaluation, testing how well the model performed, and finally deployment, putting the whole system together, hardware and software.
Going back to that business understanding, the cost-saving potential. The paper specifically mentions the Department of Public Works spending that PHP 4,000 per kilometer. An automated system like iWay could offer huge advantages there.
Absolutely. Huge financial advantages. Think about the savings, freeing up funds and people. It could be pretty game-changing for infrastructure development in regions like the Philippines, letting them redirect resources.
Yeah, definitely. And for the data understanding part, they used a lot of images, right? Over 16,000.
Yeah, over 16,000 pothole images gathered from various sources. And then they did that pre-processing you mentioned, ensuring the AI had good quality data to learn from.
And for modeling, they chose this specific AI model, YOLO 5. Why that one?
Well, the paper includes a table comparing different versions of YOLO 5. The M version they picked offered a good balance between accuracy, speed, and how much processing power it needed on that little Raspberry Pi.
So it was a trade-off.
Exactly. YOLO 5 is basically a state-of-the-art AI brain for quickly identifying objects in images. The Ying version was a smart choice, high accuracy without needing, like, supercomputer hardware. They compared the N's M and L versions on accuracy, speed, even memory use to make a really informed decision for their needs.
And the actual iWay prototype sounds quite practical, like a 3D printed case holding the Pi, camera, GPS, even a power bank.
Yeah, they tested it by attaching it to a vehicle and driving around collecting data. A real-world, hands-on approach.
But it wasn't perfect, right? The paper mentioned challenges.
Crucially, yes. Research always highlights challenges. They noted some inaccuracies with the GPS data sometimes, and the system occasionally overheating, so areas for further development.
Okay. But even with those issues, the feedback was good from the Illigan City Engineer's Office.
Yeah, really positive. The paper mentions they found it really helpful for increasing productivity and reducing survey costs. That's a really encouraging real-world endorsement.
It really is. Shows the tangible benefits these AI systems can bring. Okay, so that's a research project. Let's move to something already being tested out in the field, Oregon City.
Right, Oregon City, they're taking a really interesting approach. They're using their street sweeper.
The street sweeper, seriously.
Yeah. The KGW News Report talks about their city rover. It's a regular street sweeper, but they've mounted a camera on it that uses AI to automatically scan for potholes while it's doing its normal sweeping routes.
That's clever, integrating it into existing operations.
Exactly. Making use of existing infrastructure, the street sweeper fleet, and just adding a layer of smart tech. And the report highlights the really useful information it gives the maintenance crews.
Like what?
Well, it gives them the exact street address of the pothole, a picture of it, the date and time it was spotted,
Okay, basic stuff.
but also a link to the Google Street View of that location, and even a QR code you can scan to pinpoint it precisely on a map.
Ah, that's handy. Like an instant comprehensive pothole report generated automatically.
Pretty much. And all that info gets uploaded to a central cloud system. So Public Works can track everything and plan the most efficient repair routes.
Makes sense.
The report even had a quote from a city employee saying how hard it is to find all the potholes without public reports or this kind of tech. They just can't physically inspect every single road every day.
So this is helping them find stuff they might otherwise miss, being more proactive.
Looks like it. And the report mentioned they're currently testing the rover, but they hope to make it permanent, which suggests, they're seeing real value in it.
It's a really smart integration. Okay, now let's hop across the Atlantic to the UK. Surrey.
Yes, the BBC News article details Surrey County Council's plan. They want to install computer vision cameras in their regular highways maintenance vehicles.
A similar idea then.
Similar, yeah. These cameras will automatically detect and photograph potholes, logging them in their system for repair crews.
Okay. Anything different about their approach?
Well, what's interesting is their future plans. They're looking at expanding the capabilities to detect other kinds of road issues too.
Like what?
Things like missing traffic signs, or maybe overgrown vegetation encroaching on the road. It shows the broader potential of these systems for general infrastructure upkeep.
Right, beyond just potholes. And they mentioned safety benefits too.
Yeah, the council emphasized that inspectors won't need to physically get out of their vehicles onto potentially dangerous roads quite as much to identify these problems. That's a significant plus.
Definitely.
And they also plan to track potholes that aren't critical enough for immediate repair to make sure they get addressed later in maintenance schedules. It's about being more systematic.
Creating a data-driven approach. The article mentioned funding too, right? Surrey's investing quite a bit.
They are. $300 million earmarked for road improvements until 2028. And they talked about a lot of resurfacing work already done this year. This AI tech seems to fit into that larger effort to really upgrade their road network.
Okay, so we've seen all these different AI systems in action. But what's the fundamental tech making it all work? Let's talk about image annotation. That Cotwell YouTube video explained it well.
Yeah, image annotation is absolutely fundamental. You have these amazing AI systems, but how do they actually learn to recognize a pothole in the first place?
That's the question.
Well, as the Cotwell video points out, it's the process where humans label images with specific tags or categories. This basically gives the computer vision models the information they need to understand what they're seeing.
Like teaching a kid what a cat looks like by showing them pictures.
Exactly like that. Telling the AI, this is a pothole, over and over with examples.
And the video described different ways to do that labeling, 5 common types.
It did. There are 2D and 3D bounding boxes drawing digital boxes around the objects. So for a pothole, you draw a rectangle tightly around its edges in the image.
Okay.
Then there's image classification, where you assign just one label to the whole image, like contains pothole. They also mentioned using lines and splines for marking linear things, polygons for outlining exact shapes like the irregular edge of a pothole.
Right, they're not usually perfect rectangles.
Exactly. And semantic segmentation, which is super detailed, labeling every single pixel in the image to show what it represents. Like, this pixel is road, this pixel is pothole, this pixel is shadow.
Wow, okay. And you can see how these apply to pothole detection, right? The AI needs training data where potholes are accurately marked probably using those bounding boxes or polygons.
Precisely. That labeled data is what allows the AI to learn to recognize potholes on its own when it sees new images it hasn't encountered before.
But the Cotwell video called image annotation a human-powered task. That sounds like it could take a huge amount of time, especially with the thousands, maybe millions of images needed for good AI.
It absolutely can be incredibly time-consuming and labor-intensive.
So is there a way to speed that up? That PyResearch YouTube video talked about automatic image labeling.
Exactly. That's the next step, trying to automate that initial labeling process. The PyResearch video introduces their platform and specifically shows off their free automatic image annotation tool.
How does that work?
As the video demonstrates, users can just upload a zipped folder of images, and their server automatically tries to apply labels to them.
Automatically, wow.
Yeah. It's currently running on their CPUs, they say,
Yeah.
and allows unlimited data uploads. That could be a massive time saver for anyone working with large image datasets.
You can see how that would help. Thinking back to the iWay project with its 16,000 plus images.
Right. Manually annotating all of those would have been an enormous task. Advancements in automated labeling tools, like the one PyResearch offers, can significantly streamline that critical data preparation stage.
Making the initial data crunching much more efficient.
Exactly.
So, okay, as we look at everything we've discussed today, Edmonton predicting, Philippines and Oregon City detecting in real time, Surrey planning implementation. There's a really clear pattern emerging, isn't there?
Absolutely. There's a definite shift towards using AI and computer vision to move beyond simply reacting to potholes.
Towards being more proactive, more efficient in managing them.
Yes. The potential benefits seem really significant across the board. Cost savings through smarter resource allocation.
Increased safety for drivers and road crews.
And ultimately, just better maintained, smoother road infrastructure for everyone.
Of course, it's not all perfect yet. As the iWay paper highlighted, there are still challenges. GPS accuracy issues, needing more testing in diverse conditions.
Right. So while these technologies are incredibly promising, they're still evolving. Still in a phase of ongoing development and refinement.
There are hurdles to clear. Deploying these systems at large scale probably needs more fine-tuning, integrating them smoothly with existing city management systems.
Definitely. But if you step back and look at the bigger picture, these advancements in pothole management are really just one part of a larger trend, aren't they?
How do you mean?
Towards, intelligent transportation systems, the development of smarter, more responsive cities overall. This is one piece of that puzzle.
Right. Okay, so to kind of bring it all together then, it's pretty clear that AI is offering some genuinely innovative solutions for this age-old problem of potholes.
Potentially game-changing solutions,
Uh-huh.
yeah. By leveraging computer vision, machine learning, IoT tech.
Hmm.
We're seeing big improvements over traditional methods. Speed, accuracy, that proactive capability.
It saves time, increases accuracy, enables proactive maintenance. The key takeaways.
Definitely. And what's really thought-provoking, I think, is to consider just how much visual data is being captured every single day, all around the world. Cars with cameras, street sweepers, drones.
Yeah, tons of it.
So if AI can be applied this effectively to something as, well, commonplace as identifying potholes, what else could it do? What other unexpected and beneficial ways might this technology be used to improve our infrastructure, our daily lives?
That's a really interesting thought to end on and encourages you to think way beyond just potholes, doesn't it? To imagine the broader potential of these AI-driven visual analysis tools for all sorts of challenges.